Once speed made you untouchable, at least that's what engineers believed when they built a bomber so fast, so extreme that no missile could catch it. This was the dream behind the North American XB-70 Valkyrie, a machine designed to outrun everything on Earth. But today, the most advanced combat aircraft aren't the fastest. They're not even trying to be. Instead, they rely on something far more powerful than speed: stealth. And no aircraft represents that shift better than the Lockheed Martin F-35 Lightning II. If you enjoy deep dives into real military technology and the physics behind it, make sure to subscribe. This is VectorTechExplained. The XB-70 Valkyrie wasn't just another bomber, it was an engineering statement. In the late 1950s, the United States believed that the future of strategic bombing depended on one thing: speed at extreme altitude. The logic was simple: fly higher than enemy defenses could reach, and fly faster than anything they could launch. If you could maintain Mach 3 at over 70,000 feet, you would be effectively untouchable. And the XB-70 delivered exactly that. With 6 massive engines and a sleek delta-wing design, it could cruise at speeds exceeding 3 times the speed of sound. But what made it truly unique was how it used physics to its advantage. At Mach 3, shockwaves form along the aircraft's body. Engineers designed the Valkyrie to ride these shockwaves, generating additional lift in a phenomenon known as compression lift. This allowed the aircraft to become more efficient the faster it flew, something that almost sounds impossible. It wasn't just fast, it was optimized for speed in ways no bomber before or since has been. The materials used in its construction had to withstand extreme temperatures caused by air friction. At Mach 3, the skin of the aircraft could heat up to hundreds of degrees. Traditional aluminum would fail, so engineers turned to advanced stainless steel honeycomb structures. This wasn't just an aircraft, it was a flying experiment in pushing the limits of aeronautical engineering. On paper, the XB-70 looked unstoppable, but reality had other plans. While the Valkyrie was being developed, the nature of air defense was changing rapidly. Surface-to-air missiles were becoming more advanced, faster, and more accurate. Radar systems were improving. And most importantly, interception no longer relied solely on chasing a target. It became about predicting where that target would be and launching a missile to meet it there. Speed, which once guaranteed survival, started to lose its advantage. Even at Mach 3, the XB-70 could be tracked. High-altitude flight made it visible to radar over long distances, and once detected, it became a target. Missiles didn't need to catch up from behind. They could be launched ahead of the aircraft's path. Suddenly, being fast wasn't enough. It might even make you easier to predict. This was the turning point, the realization that changed everything. The United States began to question whether speed was the right solution at all. If you couldn't outrun detection, maybe the better strategy was to avoid being detected in the first place. This idea led to one of the most important shifts in military aviation history: the move from speed to stealth. Instead of designing aircraft that could escape threats, engineers began designing aircraft that would never be seen. That philosophy eventually gave rise to stealth technology, and decades later it evolved into aircraft like the F-35. At first glance, the F-35 might seem unimpressive compared to something like the XB-70. It's slower, much slower. It doesn't push Mach 3. It doesn't rely on extreme altitude. In fact, if you judged it purely on speed, it might look like a step backward. But that's exactly the point. The F-35 doesn't need to outrun threats because it's designed to avoid them entirely. Its shape, materials, and internal weapon bays are all optimized to reduce its radar cross-section. Instead of reflecting radar signals back to the source, it scatters them away. To radar systems, it appears dramatically smaller than it actually is, but stealth is only part of the story. What truly makes the F-35 powerful is its ability to see everything around it. Through a combination of advanced sensors, data fusion, and network connectivity, the aircraft builds a complete picture of the battlefield in real time. It doesn't just rely on its own radar, it integrates data from multiple sources, processes it, and presents it to the pilot in a way that allows for faster and more informed decisions. This is where the philosophy completely changes. The XB-70 was built to survive by escaping. The F-35 is built to survive by knowing. In modern air combat, the aircraft that sees first usually wins. It can engage targets before being detected. It can choose when to fight and when to disengage. Speed becomes secondary to information, and this is why Mach 3 bombers disappeared. The problem wasn't that the XB-70 failed as an aircraft. In many ways, it was a success. It proved that sustained Mach 3 flight was possible. It demonstrated new materials and aerodynamic concepts. It pushed engineering forward. But it was built for a world that no longer existed. As missile technology advanced, high-speed, high-altitude bombers became vulnerable. At the same time, new approaches like low-altitude penetration and eventually stealth offered better survivability. Aircraft like the B-2 Spirit took this concept even further, focusing entirely on minimizing detection rather than maximizing speed. The shift was clear. Survival no longer depended on outrunning threats, it depended on avoiding them. Today, aircraft like the F-35 represent the culmination of that shift. They are not the fastest machines in the sky, but they are among the most capable, and yet the debate continues. There are still those who argue that speed could make a comeback. Hypersonic weapons, advanced propulsion systems, and new materials are pushing the boundaries once again. Could the future bring a return to high-speed aircraft? Possibly. But if it does, it will likely combine speed with stealth and advanced sensors, rather than relying on speed alone. Because the lesson of the XB-70 is clear, speed alone is not enough. The battlefield has changed, detection systems have evolved, and survival now depends on something far more complex than raw performance. It depends on staying invisible, staying informed, and staying ahead. So what really wins in modern air combat? Is it the raw power of Mach 3, represented by the XB-70 Valkyrie? Or is it the quiet, calculated dominance of stealth, embodied by the F-35? The answer might not be as simple as choosing one over the other, but history gives us a strong clue. Speed made you hard to hit. Stealth makes you almost impossible to find. And in a world where being found means being targeted, that difference changes everything.